We now determine the value of c such that it satisfies this mean value theorem for the function f of x equals x cubed plus 12x squared plus 7x on the interval negative 4 comma 4, which is a closed interval. So first, let's revisit this mean value theorem. That is, if a function f of x is continuous on the closed interval a comma b, and the function is differentiable on the open interval a comma b, then there exists a point C such that f prime of C equals f of B minus f of A over B minus A. So we are going to use this mean value theorem to determine the value of C. Okay, so to use the mean value theorem, we need to ensure that the function is continuous on the closed interval a comma b. So here we have this function f of x, and let's check that if this is continuous on the closed interval negative 4 comma 4. Looking at this function f of x, we see that clearly this is a polynomial function in x. So all polynomial functions are continuous in the domain. All polynomial functions are continuous in their domain. So this function is continuous on this interval negative 4 comma 4. So we have verified that it satisfies the first continuation, that is first condition, that is it is continuous. And now let's check if it is differentiable. Once again, we can use the same justification that all polynomial functions are differentiable on their domain. So we see that this function f of x is differentiable on the interval negative 4 comma 4, and this means we can now utilize the mean value theorem such that we see that f prime of c, and this equals f of b minus f of a over b minus a. Now let's replace the b and a. So this is a and this is b. So I'm going to replace a by negative 4. So I can rewrite this f prime of c, and this equals f of b is becoming as f of 4 minus f of a is we have to find f of negative 4 and divide by b minus a, that is 4 minus of negative 4. So this simplifies to, that is 4 minus of minus 4 is 8. So I can just rewrite this as 8. So this is the equation that we are going to use to determine the value of C. Okay, so now let's evaluate the left side expression. That is, we have f prime of C. To determine f prime of C, basically we have to determine f of f prime of x. So first, let me copy the f of x. We have f of x equals x cube plus 12x squared plus 7x. So I'm going to find its derivative. That is, I write down f prime of x, which is the derivative of the function f of x. And we have to find the derivative of each of the terms. So the derivative of x cube is using the power rule. It is 3x squared. And if we find the derivative of 12x squared, it is 12 times of derivative of x squared using the power rule is 12x. So I put 2x here, and then we have this 7x. Its derivative is 7 because 7 times of derivative of x is 1, so it's just 7. So now we can find f prime of c. So all that we do is we replace x by c. So therefore this becomes f prime of c. This equals replace all c by all x by c, becomes 3c squared, and this is 12 times 2x is 24x, and we will also replace x by c plus 7. So we got the left side expression, and we now evaluate the right side expressions. That is, we have to evaluate this quotient. For that, we need to find f of 4 and f of negative 4. So let's find f of 4. We have to plug in x equal to 4 into the function f of x. So f of 4 equals I replace x by 4, it becomes 4 cube plus 12 times of 4 squared plus 7 times of 4. And this equals 4 cube is 64 plus 12 times of 4 squared is 16 plus 7 times of 4 is 28. So we get 64 plus 12 times of 16 equals 192 plus 28. So basically we have to add these three numbers, that is 192 plus 28 plus 64, and this equals 284. So we found f of 4. Now let's find f of negative 4. We replace x by negative 4 in f of x. So it becomes negative 4 quantity cube plus 12 times of negative 4 quantity square plus 7 times of negative 4. Let's evaluate this. Negative 4 cube is negative 64 plus 12 times of negative 4 square is a positive number 16 plus 7 times of negative 4 is negative 28. So I put negative 28. So this is negative 64. And once again, 12 times 16 is 192 minus 28. So when we evaluate this, we get 192 minus 64 minus 28. And this equals 100. So we found the f of negative 4. So let's find the right side expression. Right side expression is f of 4 minus f of negative 4 over 8. So this equals, let's substitute f of 4, which is 284, minus f of negative 4 is 100 over 8. So this equals 184. 284 minus 100 is 184 divided by 8. And when we divide this, we get 23. So this is the right side value. So let's plug it into our mean value theorem equation. That is, we have to plug it into this equation. We will substitute the left side as plus the right side values. The left side, we have to use this f prime of c, that is 3c squared plus 24c plus 7, and this equals the right side value is 23, which we have just found. So I put 23 for the right side. Now we have to simplify this and evaluate. I'm going to subtract 23 from both sides. So when I do that, I get 3c squared plus 24c. 7 minus 23 is negative 16, and this equals 0. So basically, this is a quadratic equation in the variable c, which we can determine the value of c by factoring method or the quadratic formula method. I'm going to use the quadratic formula method. So first, let me identify the a, b, and c. This is a, this is b, this is c. We are using the standard quadratic form, that is ax squared plus bx plus c, if this is the quadratic equation. And the quadratic formula is x equals minus b plus minus under the root of b squared minus 4ac, and this is all over 2a. So I'm going to use this quadratic formula. So here, since I solve for c, I put c, and this equals negative of b, that is negative 24 plus minus square root of b square, that is 24 squared. We then put minus 4 times of a is 3 here, and c is negative 16. And this is all over 2 times of a, which is 3. Okay, so let's simplify and evaluate the value of c. So in the next step, I write c equals negative 24 plus minus 24 square is 576, and this becomes a positive quantity. This is negative 4 times of 3 and multiply with negative 3. So this will become a positive quantity. 4 times 3 is 12, and then 12 times 16, which is 192. So it's positive 192. So I put positive 192, and this is under the root. Over 2 times 3 is 6. So let's evaluate this. This is negative 24 plus minus. We add these together. We add 576 with 192, which is 768. And this should be under the root divided by 6. We can now simplify this under the root expression by writing this as a product of perfect square. So I put negative 24 plus minus. The biggest perfect square number is 256 times 3. That is 768 is written as 256 times 3. So we get over 6. And we know that square root of 256, and this equals 16. So we put C equals negative 24 plus minus. This will become 16 times root 3, and this is all over 6. Let's write this. We have two solutions here. That is negative 24 plus 16 root 3 over 6, comma, negative 24 negative 16 root 3 over 6. We can simplify this further. That is C equals, I can write down this as a two fraction, negative 24 by 6 plus 16 root 3 over 6, and this is also negative 24 over 6, negative 16 root 3 over, I'm sorry, this is 6. Let's simplify this. So we have C equals, this goes negative 4 times, and here also it is negative 4 times. We can simplify this. This is 8 times 2. So 8 times 2, and this is 2 times 3. This means I can cancel these 2's, and I'm just left with 8 over 3. So the first value is negative 4 plus 8 root 3 over 3. And similarly, the second value is negative 4 minus 8 root 3 over 3. And out of these two values, we clearly see that only this value, that is this value of C, lies in the given interval negative 4 comma 4. So we consider only this value which satisfies this equation or the function. This value does not lie in the given interval. So therefore, we see that the value of C that satisfies the mean value theorem for the given function is negative 4 plus 8 times root 3 over 3. This is the exact value of C. And if we need this in terms of decimal, we can plug this expression into the calculator, and when we do that, we get the value of 0.6188. This is approximately 0.6188. This is exact value, and this is in decimals.